This video is going to cover Unit 18-2. So we're going to continue our discussion on quadratics, but before we get into that any further, I want to talk about taking the square root of a number. So far, like let's say we want to take the square root of 25. The square root of 25. That is equal to, most people would say that is equal to 5. That is only partially correct. When you're taking the square root of a number, what you're doing is you're saying what number times itself equals the number under the radical. So 5 times 5, or 5 squared, is 25. That is correct. But there is another number that I can multiply by itself to get 25, and that number is a negative 5. So 5 squared equals 25, and negative 5 squared equals 25. Because, oops, I put a 5 right there. That's funny. 5 times 5, positive times positive is 25. Negative 5 times negative 5, negative times negative is positive, so that equals 25. So from now on, whenever you take the square root of a number, we are going to have, the answer is going to be 2. There's going to be 2 answers. So the square root of 49 is equal to a positive and a negative 7. And this is often the way we write that, with a positive over top of a negative. This is 2 numbers, positive 7 and negative 7. So that's where we get our 2 answers from when we're solving quadratics. Okay, so 8-2 deals with what we call incomplete quadratics, or they also call them pure quadratics, and they are in the form of a times x squared is equal to some constant c. So let's take a look at the example on the bottom of page 496, where we have 6x squared is equal to 54. Now we have already solved problems similar to this. The first thing that we're going to do is we divide by 6, makes that a 1. Divide this side by 6, so x squared is equal to 54 divided by 6, 9. Now, remember we took the square root because we have something squared, so we need to take the square root of it. So we also need to take the square root of this side. So x will equal 3, and there's different ways you can write this. I can write it this way. That indicates that it's 2. Or you can just write 3 and negative 3, something like that. So there are 2 answers to this quadratic right here. Now, if you went back to the original equation and you put 3 in here, you would come up with 54. If you put a negative 3 in there, you'd come up with 54. Okay? So, now this is a side note, just a little extra. If I take a number, let's say negative 5, and square it, versus negative 5 squared, we get different answers. So it's important where we put the negative. If the negative is being squared, we're going to have a positive number. If the negative is not being squared, we're going to have a negative number. Because this means 5 times 5, which is 25, and then put the negative on it. This means negative 5 times negative 5, because the negative is within the parentheses of being squared. Just a little side note there. So when I substitute these numbers back in here, I would substitute it this way. 6, let's do the negative 3 first. Negative 3 squared like that. And the other would be 6 and then 3 squared like that. Okay, so let's take a look at some examples of this. Let's take a look at example number 2 at the top of page 497. We have 4x squared minus 3 equals 7x squared minus 51. Okay, well this doesn't look exactly like this right now, but we can manipulate it so that it does. So we want to get the x squared terms on one side and then the constant terms on the other. So let's go ahead and subtract 4x squared from this side, add 51 to this side. So subtract 4x squared here and add 51 here. We come up with 3x squared over here, and then 48 over here. So dividing both sides by 3, dividing by 3, let me make sure it's in the screen. So we have, let's see here, 16 equals x squared. Take the square root of both sides, and I will have x is equal to plus and minus 4. Okay, so sometimes when you're solving, you will not have an even square root. Okay, so there's two ways that you can satisfy that for this class. You could, like let's say for example, you do a problem and you come up with x is equal to the square root of 7. Now 7 doesn't have an even square root. So you could leave it just like that. Of course we need to have the positive and negative of that. Or you can put it in your calculator and round off the square root of 7. Don't round it too far, 3 decimal places. Square root of 7 is equal to 2.65 plus and minus 2.65. That'll work as well. I'm not too awful picky about how you round it exactly, but it can't be too far off. The best way to do it is just to leave it just like that, called an exact answer. Okay, so let's take a look at, I don't really like that one. Let's look at, on page 498, let's look at one of them. Let's look at number 7. So I have x squared is equal to 144. Okay, the square root of that and the square root of that. Square root of 144 is 12. That's not very neat. 12, so x is equal to plus and minus 12. Okay, so let's take a look at some that are a bit more challenging. I don't want it that way. There is a difference the way the paper lays. Okay, let's take a look at, oh, there's a couple interesting ones in here. Number 25. Number 25. Okay, we have x divided by 4 is equal to 16 divided by x. So we're solving for x here, so we need to cross multiply. So we have x times x is x squared. And let's see here, 64. So the square root, so x would equal, the square root of 64 is 8. So we have plus and minus 8. Let's take a look at another one similar to that, number 27. Yeah, number 27. So we have x minus 7 over 2 is equal to 8 over x plus 7. So once again, we're going to cross multiply. And I'm going to do this over here because what I need to do is I need to FOIL that. So I have x minus 7 times x plus 7. Now if you recognized these as conjugates, it would make it simpler. But we're not going to cover conjugates. But if you recognize it, it would make it simpler. So we go first is x squared. The inners is minus 7x. The outers are plus 7x, and then the lasts are a minus 7 times 7, which is 49. Now this simplifies. These two center terms cancel out, so it's x squared minus 49. So that's what's on one side. So on the other side we have 16. So 16 equals x squared minus 49. So we add 49 to both sides. And we get 565. Take the square root of that, take the square root of that, and x will equal plus and minus the square root of 65. No even square root in that one. Number 29, that's another one that you would FOIL before. Those are conjugates too, so the center two terms will cancel each other out there. 30 is the same way. Let's see, let's do one of the application problems. Let's see, is that one good? Maybe I should have looked at these before. I'll just pick one. One that I can read, preferably. Okay, number 37, an object fired with an initial velocity feet per second in feet is given by the formula h is equal to that. Compute the velocity needed to fire a projectile. Okay, so the height we already know. So what the equation is, h is equal to v squared divided by 64. And this is a physics problem. If you took a physics class, you would learn this equation right here. It actually is a derivative of another equation, but they give you the equation and then they give you the height. So 3780 is equal to v squared divided by 64. So to solve this, we multiply 64. So this becomes a 1. So 3780 times 64. Not going to try that in my head. Ooh, it's a big one. 241,920 is equal to v squared. So I have that in my calculator right now. I'm just going to take the square root of it. And my calculator pulls out the even square roots. You could just make it a decimal if you wanted to. So plus and minus, well, what do we have here? 491.85 equals velocity. You could also say, let's see, what does that come out to be? Plus and minus 48 times the square root of 105. That's the pulling out the even square roots. Okay, but we're not done with this problem yet. Okay, we solved for the two answers. However, whenever you're solving one of these physics types problem, let's read the problem again. It says an object fired with an initial velocity v in feet per second reaches a height of h is given by the formula. So they give you the formula. Compute the velocity needed to fire the projectile 3,780 feet. Give the answer to the nearest foot per second. So I would round this up to 92. So it's plus and minus 492. Okay. So this is one of those situations where minus 492, that doesn't make much sense because we're looking at velocity. How can you have a negative velocity? Okay, maybe if you're like falling into a black hole or some weird thing, you can't have a negative velocity. So when you solve these quadratics in a physics problem, you're going to have one answer that doesn't make any sense because it's going to be negative when you can't have a negative. So the answer is the positive side. So the velocity is 492. Even though when we solved it, we got the positive and the negative, but the negative can't be, so it's got to be the positive 492. Now when you're solving one of these types of problems, oftentimes you're solving for time as well, these physics types of problems. So one of your answers is going to be positive, the other one's going to be negative. Obviously we can't have a negative time because they only made one DeLorean with a flux capacitor in it. So, and I don't think any of us own that one, so we can't have negative time. Yes, that was a joke.